So we have done that Mendeleev's periodic classification. According to Mendeleev's periodic classification, according to Mendeleev's periodic classification, according to Mendeleev's periodic classification, elements are arranged. Periodic classification, elements are arranged. Elements are arranged on the basis of their elements are arranged on the basis of their
weight.
on the basis of their
Atomic weight.
Their atomic weights. Their atomic weight. What modern periodic classification is? This modern periodic classification is, instead of atomic weight, it is based upon atomic number. According to modern periodic classification, according to this modern periodic classification, that is modified periodic classification, elements are arranged on the basis of their atomic numbers. And who gave this modern or modified version of periodic classification? This was given by Moseley. Who gave this? Moseley. So this is known as Moseley's modern periodic classification, or this even atomic number concept was also given by Moseley. Who gave this atomic number concept? That is Moseley. And who gave this modern periodic classification? That is also Moseley. Then range, Bohr, Werner and Bury. Bohr, Bury, you know not, in 10th class this was there. Bohr-Bury's rule or Bohr-Bury's concept in there in electronic configuration also I explained you that. So range, Bohr, Werner and Bury gave this long form periodic table. This long form na 18 groups, 2 groups here, 6 groups here, 10 groups here. So this long form periodic table, and 1, 2, 3 and then 4th, 5th, 6th and 7 periods. So this long form periodic table was given by Range, Bohr, Werner and Bury. Now see, elements were classified into S block. Elements were classified into S block, P block, D block and F block. Who classified elements into SPDF? It was Bohr only, Niels Bohr only, who classified elements into S block, P block, D block and F block. Now see, S and P block elements are known as normal, typical or representative elements. S and P block elements, Bohr named them normal, typical or representative elements. Why? Why normal elements? Because if new incoming electron enters into the last shell, that's a normal. So since in S and P block, new incoming electron enters into the last S and P subshell respectively, so S and P block elements are called normal or typical. What about representative elements? C, carbon, silicon, germanium, tin, lead. This is known as carbon family. So first member of the group represents the entire family. So it is representative elements. Lithium family, beryllium family, boron family, carbon family, nitrogen family, oxygen family, fluorine family and helium family. So since the first member of the group represents the properties of entire group, that is why it is called representative elements. Now see, what about D block elements? Bohr named them transitional elements. Why transition? Because see, this is S block, this is P block, and in between them, in between S and P block elements, D block elements are there. That is why D block elements are called transition. Transition means in between. Transition means in between. Since these D block elements are there in between S and P block elements, these D block elements are there between highly electropositive and highly electronegative elements. These D block elements are there between metals and non-metals. That is why D block elements are called transitional. Many more reasons are there that we will discuss there in D block. Why D block elements are called transitional elements. So we'll discuss it there. Even in bonding also we'll discuss that. Now Bohr named F block elements as inner transitional elements. Bohr named F block elements as inner transitional elements. Why? See, this is lanthanum. 57, and after that this is 72. After 57, then next is not 58, next is 72. So where these 14 elements are, these are here.
Yeah.
So
Very
since these
long.
14 elements are there inside the transitional elements, inside that block, that is why these F block elements are called inner transitional elements. Here see,
Yeah.
this is 89. After 89, 103. After
Yeah.
89, what next is?
103.
103. So from 90 to 103.
Yeah.
So,
Yeah.
sorry, 104. 104. 90 to 103 are here, are called actinoids, are there in F block. So here 14 elements here and 14 elements here. So that is why these elements are called inner transitional elements. See, in some books 57 and 89 both are written here. 57 is written here, 57 is written here, and 89 is written here. And if
Yes,
we'll
sir.
count these elements also there in this block, lanthanoids and actinoids, then these elements will become 15 in number. That is not possible, because in F, how many electrons can be accommodated? In F, 14 electrons can be accommodated. So only 15 or blocks will be there. 15 blocks will be there. But instead of 14, sorry, I have said 15, 14 blocks will be there. And if 15th element is there, then 15 blocks, and in F 15 electrons are not possible, only 14 electrons can be there. So that's
Yes,
the
sir.
reason. So that's wrong. Now zero group elements, Bohr named it inert gases, rare gases, noble gases, or aerogens. Zero group elements are called noble, rare, or inert gases or aerogens. So Bohr classified elements into S, P, D, F and zero group elements. Bohr classified elements into S, P, D and F blocks. And other than this SPDF block, zero group elements, this orange, this pink colored, that is also there. So now see, you have classified elements into different blocks SPDF. And now with the increase in atomic number, why you have arranged elements on the basis of this increasing atomic number? Before Mendeleev's classification, elements were classified before that too, but there was no fundamental, there was no scientific reason was there was no fundamental property was there based on which we can classify the elements. Mendeleev was the
Yes, sir.
first one who classified elements on the basis of some fundamental property, that was atomic weight. And second was modern modified period classification, which was given by Moseley. This classification also was based on some fundamental property, some scientific property, and even was more modern than that, Mendeleev's period classification too. Now see, so there must be some resemblance or some sequence there in their physical and chemical properties will be there. Either increasing or decreasing order will be there in the physical and chemical properties of the elements. That is why we have classified elements into different groups, different blocks, and different periods. First, hydrogen, lithium, sodium, potassium, they all are there in this, they all are there having the same physical and chemical properties. That is why we have classified them there in the same group. Their
Yeah.
periodicity will be there. What's the meaning of periodicity? Periodicity means a regular increase or regular decrease, a regular trend, that is called periodicity.
Yeah.
So there will be periodicity in their physiochemical properties. What properties?
Physical.
Physiochemical properties means physical and chemical properties. You can say periodic. Since there is periodicity in these properties now, so these properties are called periodic properties. Periodic properties means physiochemical properties, means physical and chemical properties. Once this modern periodic classification will get over now, then the second part of this chapter we will be doing, that is called periodic properties. So first part, as I told you there on the very first class related to this chapter, that two parts are there. One is periodic classification and second is periodic properties. So periodic classification, this is the last topic there in the periodic classification.
Okay.
Now see, as I already told you, you have classified elements into S block, P block, D block and F block. We have already classified elements into S block, P block, D block and F block. Now see, this point is very important and very confusing too. This red color, na? This red color is North American system. S block elements, P block elements are A group elements and D block elements are B group elements according to which system? North American system. Except NCERT book. In every book for entrance examination, this North American system is followed. But in NCERT book, rest of the world system is followed. I don't remember there in your ISC books which system they have followed, that you need to check, but you should know both, na, whatever they may be asking you. So this blue color, na, this blue color, S and P block elements are B group elements and D block elements are A group elements. This blue colored system is rest of the world system. Rest of the world system. So two types of systems are there. One is rest of the world system and another is North American system. So we should know both. You can write third A as well as third B. So that depends what they are going to ask you. Third A and third B. Third A or third B. So that depends which system you are talking about. Accordingly, you will be classifying. Now see, there is one more point related to your entrance examinations, or you can say your board exams. Magnesium is known as a bridge element. What bridge element is? See, bridge elements means between two elements now. Between two elements, ionization energy of calcium is 590 and ionization energy of zinc is 900. What about the ionization energy of magnesium? Greater than calcium and lesser than zinc. Calcium is second A na. Whenever I will be talking about group, I will be using North American system. So second A. And what about zinc? Zinc is second B. So between second A and between second B, the zinc is the, this magnesium is the bridge element. Is the bridge element. So that is why third period elements resembles with calcium second A as well as zinc second B. Magnesium is third period element na? Yeah. So that is why magnesium is known as a bridge element. So it is not common everywhere, but since related to magnesium it is there, that's why they are telling it as a, they are calling it as a bridge element. Is it okay? Yes, sir. All these are small questions. Okay. Now see typical elements. Now see typical elements. What typical elements are? Third period elements are called typical elements because are true representative of groups. True representative of groups, what does it mean? They will be having average of the properties of all elements. Carbon will be having the average of the properties of all these elements which are there in their group. That is why these first member of the group, are called representative elements. Fine. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, all these are representative members there in their respective groups. Na belong to entire group, not lithium, in terms of properties. Fine. Now see what the next is. Shell model of the atom. See, this is very important. 1, 2, 3, 4, 5, 6, 7, 8. D block elements in the beginning itself, I have already told you, D block elements show variable valency. So here we won't be talking about the valency of the D block elements. Here we will be talking about the valency of S and P. These are S block elements and these are P block elements. First A, second A, third A, fourth A, fifth A, sixth A, seventh A, and zero group according to North American system. Fine. So here, what will be the valency? 1, 2, 3, 4, 3, 2, 1, 0. Valency first increases. 1, 2, 3, 4, 3, 2, 1, 0. First increases 1, 2, 3, 4, 3, 2, 1. Now see, you have to give compounds also in support of your answer. You have said that valency of this first is 1. So you have to give proof of this too. So NaH. How many H you have taken with Na? 1. So the valency of Na will be 1. Now see, CaH2. Here 2. This 2 is coming downside. A space was not there, na? So this 2 is coming downside. Now see, how many hydrogens are there with calcium? 2. So the valency of calcium is 2. What about AlH3? This 3 is written downside. So how many hydrogens are there? 3. So the valency of aluminium will be 3. CH4. How many hydrogens we have written? 4. So the valency of carbon is 4. Now see, NH3. How many hydrogens are written? 3. So the valency of nitrogen will be 3. H2O. How many hydrogens are written? 2. So the valency of oxygen will be 2. HCl. How many H are there with Cl? 1. So the valency of Cl will be 1. So this is valency with respect to hydrogen.
Hydrogen,
With respect to hydrogen. Now see, with respect to oxygen and halogen. 1, 2, 3, 4, 5, 6, 7, 0. This table, etc., you won't be getting there in the books. But what theory it is written there in the books, I have converted them into graph, or sometimes I'll be converting into diagrams too. So whatever I have written, I want to write my own chemistry books. So many things are there which are not there in books. But I took from questions from all these different exams and from different books and wrote it here. Fine. So with a reference to halogen or oxygen, see here NaCl. How many Cl are there? 1 Cl.
There's only 1 Cl.
So the valency of sodium will be 1. Now see, magnesium chloride, MgCl2. How many Cl are there?
2.
2. So the valency will be 3. AlCl3. So valency will be 3. CCl4, PCl5, SF6, IF7, and this can't form any compound. See, I have taken here SF6. You can't write OF6. You have to prove your answer right now.
Yes, sir.
You can't write OF6. You can't write NCl5. So you should know this all, then only you can handle. Here, this all. C 1, 2, 3, 4, 5, 6, 7. That's why you have written valency 1, 2, 3, 4, 5, 6, 7, 0. Now see, with reference to oxygen, Na2O. What is the valency of oxygen?
2.
2. So 2 sodium are there with 1 atom of oxygen. So 1 sodium will be having 1 valency. Now see, here MgO. What is the valency of oxygen? 2. So how many magnesium atoms you have taken? 1. So magnesium valency will also be 2. Now see this one. Al2O3. Al2O3. What is the valency of aluminium? 3.
Yeah. And
cross multiplication na, and the valency of oxygen will be 2. So aluminium is 3, oxygen is 2. Now like this, we will keep on writing like this too. CO2, P2O5, SO3, SO3. Valency of oxygen is 2. How many oxygens we have taken? 3. So this will become 6. So this will also be 6. Then I2O7. I2O7. So that's all. This table is very important, will help you a lot in making your chemistry easy. Fine. So this
Yeah.
is all about the valency with respect to hydrogen and with respect to oxygen and halogen both. Valency is a very, very important, very big and very difficult topic. One of the difficult most topics there in the chemistry. Whatever difficulty you will be having in chemistry, it may be because of this. Not only in your 11th class, but in 12th class also, this will be playing very crucial role in electrochemistry, in solution, in inorganic chemistry, in basic concepts, some mole basic concept that was your first chapter there in 11th class. So everywhere this will be playing very crucial role. So it's a very
Okay.
important topic. You should be well versed there in oxidation number, charge, and valency. That's a very important thing. My YouTube
Yes.
video is also there based on this. My YouTube
Okay.
channel is there on my name only, Abdul Wajid Haider. So there
Okay.
also I have made 5-6 videos based on this oxidation number, charge and valency. So you can see that too, and if you have any difficulty, then again you can ask me there in the next class, because that's a very, very important topic. Now see, for what
Okay.
chemistry is there? For what chemistry is there? For what chemical reactions are there? For what chemical bonding is there? Just for one thing, that last electron, last shell must have 8 electrons. Entire
Yes.
chemical bonding is there, chemical reactions are there, chemistry is there. For what? So that each and every element will have 8 electrons there in the last shell. That is S2P6. S2, that is 2 electrons, and P6, that is 6 electrons. So total is S2P6. S2P6. That is called octet. That is called octet. That's a classical concept. That's a
Okay.
classical concept.
Okay.
If you remember this point, you will never make any mistake in chemistry. Each and every element tends to have 8 electrons there in the last shell. Because when 8 electrons will be there in the last shell, that state will always be the more stable state. That state will always be the more stable state. Is it okay?
Yes, sir.
So this is classical. What modern is? Unpaired electrons should get paired. Unpaired electrons should get paired, because when electrons will be paired, that state will always be the more stable state. That state will
Okay.
always be the more stable state. So each and every element tends to have that stable state. So this is what chemistry is. This is what chemical bonding is. This is what chemical reactions are. Fine. This is what chemical
Yeah.
bonding is.
Yeah.
This is what chemical reactions are. This is what chemistry is. Fine. Just a
Yes.
minute,
Yeah.
please. Just a minute, please.
Okay.
Sorry.
Yeah.
So see what your first target is. See why you are joining this class. Why I am taking your class, so that tomorrow we are taking
Yeah.
class, so that we can be stable today there in your life, there in our
Yeah.
life.
Yeah.
Sorry, what happened? This just a minute.
Yes, sir.
I'll share once again.
Yeah. Yeah.
See why you are attending this class, why I am taking your class. I am taking your class so that today I can be stable there in my life.
Mm-hmm.
Means earning money.
Yeah.
And then why you are taking this class? You are taking this class so that tomorrow you can be stable there in your life. So what our target is? Stability there in life.
Mm-hmm.
And how we will be stable there in our life? When we will be having plenty of money, then we will be stable there in life. When we will be having plenty of money, then only we will be stable in life. So this is your first target, that each and every elements have 8 electrons there in the last shell. This is your first target. That's called octet rule. This is classical concept, old concept, not the modern one. What modern is, all unpaired electrons should get paired. That's why I taught you that box electronic configuration, orbital electronic configuration. If you will be well in that all 12 points now, then you will enjoy a lot, not only periodic classification, but you will enjoy a lot chemical bonding also. So before starting chemical bonding, you should revise it so that you can get good idea about the chemical bonding. Otherwise, chemical bonding is a very, very difficult concept. It's a very difficult, very vast concept, but you will be handling it very, very easily if you know 12 points. So revise it before starting the chemical bonding. And if you have any doubt, you can ask me. Otherwise, you won't be able to understand chemical bonding. Now see, and chemical bonding is a chapter which will be there in 12th class also.
Yeah, yeah.
Chapter won't be there, theory won't be there, but its application will be there. Na? Without knowing chemical bonding, we can't do well there in the 12th class in organic chemistry. See, the modern concept is what? 2 electrons. Unpair, what's the meaning of 2? 2 means duplet. What's the meaning of duplet? Means all unpaired electrons should get paired. Is it
Yes,
okay?
yes, sir.
This is the classical one, this is the modern one, but even after this modern, what modern doesn't mean 100% correct. Modern means most correct.
Yeah, yeah.
And it can't be, it can never be 100%.
Yeah.
So highest correct percentage will be most modern. But this duplet is most modern, but won't be able to explain NO, won't be able to explain NO2, won't be able to explain ClO2, won't be able to explain Br3O8. Here in all these cases, if you are good in periodic table, then you will understand all these points and you will be answering even those questions which are not there in your book. Then also you will be,
Yes, sir.
then also actually see what exam is. If teacher's level is this and yours level is this, you won't be scoring good marks. If your level is this and teacher's level is this, then only you will be scoring good marks. So
Yeah.
our level will be like this, our level will be like this, even higher than what they will be going to ask you there in IIT JEE or SAT, whatever it is, you will be handling everything. But this all you should be good in periodic table, then only you can enjoy. So all these things here, neither octet will be completed nor unpaired electrons get paired, then also stable. So these are exceptions, and these are examples of odd electron bond. These are examples of odd electron bond. Here electrons will not get paired, here electrons will not get paired, then 2 will be stable, then 2 stable. Odd electron bond, odd means 1 will be unpaired, na? Even means paired, 2, 4, 6 paired, odd will never be paired. So 1 or more than 1 electrons will remain be unpaired. Electrons are not getting completely paired, then too it is a stable. So exception. So this we need to work very hard. All the 3 topics are there, and I'll tell you later what's there in bonding. Some parts I'll be telling you there in the bonding, so that we can come to know about this odd electron bond very easily. But if you will be good in periodic table, then only I can make you understand, then only you will be giving me all these answers. I won't be telling you in books answers are not there, then also you will give the right answer. You'll be ahead of even your books, your teachers too. Fine. So there you should be good, man. Now the next one, defects of modern periodic table. Even your modern periodic table is not able to justify the position of hydrogen. According to modern periodic table, position of hydrogen is first A. But some scientists used to say it is there in the 7th A.
Yeah.
So in hydrogen chapter, there in your part 2 chemistry, there you will be discussing why hydrogen should be kept there in first A, why not first A. 2 topics. Then third topic, Why hydrogen should be kept there in 7th A? Then why not 7th A? So these 4 questions they may be asking you. Then Franklin said hydrogen must be there in 4th A. Between them. See, first A, second A, third A, na? 1, 2, 3. 7th A. 5th A, 6th A, 7th A. 1, 2, 3. Equidistant from both places, na? From first A as well as 7th A. From both these places, it is there in the center, na?
Yes, sir.
It is there in the center. So Franklin said that hydrogen must be kept there in the 4th A group. Hydrogen must be kept there in the 4th A. Chemistry is very easy, beta. You are having maths or bio?
I'm having maths, sir.
Maths. But for maths students, it is one of the difficult most subject. But
Yes,
if you know the right method of studying chemistry, na, then it is the easy most. We will be giving minimum time. For maths, you will be giving maximum time and will be getting the lowest marks. But in compared to maths, if you will do chemistry will be taking least time and will be giving you maximum marks. So heaviest presence will be of this chemistry. It is not easy. You should know the trick. Then only. If you score good marks in chemistry, then only you can be there in JEE. Otherwise, you won't get selected there in IT JEE. So we must score good marks in chemistry, then only we can be there in IT JEE or there in any other professional college. So position of hydrogen, four points are there. These are 4 questions. And the 5th point, Franklin, that hydrogen must be placed there in the 4th group between 1st A and 7th A, equidistant from both positions. Now see, in modern periodic table, barium is in 2nd A and lead is in there in 4th A. Barium is there in 2nd A and lead is there in the 4th A. Both are having same properties, but their position is different. So why their positions are different but their properties are same? If properties are same, they should be placed together. But there was no answer for this question.
Yes, sir.
Dissimilar elements placed together. See, copper, Ag, Au, they are placed in first B group. They are placed in first B group. They are placed in first B group. And alkali metals are there in first A. So now in long form periodic table, both are there in the 2 different groups, but that time it was there in the same group. So these are heavy metals and these are light metals. So they should not be kept together. So both were there in the first group. Now metals and non-metals have no separate positions. See P block. These are metals, these are non-metals, and here it is metalloids or semi-metals or semi-metal. So what's the reason? Why is all elements are there in the same block? This answer was not there in the modern periodic table. Different, these elements are different, so their position should